Hello and welcome to welcome to Fluid Earth. This is going to be our first video on the topic of oceans and climate, and we're going to be briefly going into polar oceanography. So let's get started. All right, so first we're going to talk a little bit about the land ice forms of the polar region. So sea ice shelves, ice sheets, and polynyas. So sea ice is formed from frozen seawater, so it's a little bit saltier than your typical glacier ice. It's also very sensitive to the season, so you'll see a lot of sea ice during the colder seasons, and then you'll see like a retraction of the sea ice in the warmer seasons. That's all totally normal. It's in the general cycle of Arctic sea ice, but recently it has been, or the amount of sea ice has been decreasing due to warming polar climates, so that is unfortunate. Sea ice shelves are pretty analogous to the continental shelves we talked about kind of here too in the other video. So they extend over the open ocean and are connected to the continental shelf here at this grounding line. They just float top of the ocean, and they're just exciting. I don't know, that's what an ice shelf is. They range in length, and yeah, that's pretty much it. And polynyas are open areas of water that are generally surrounded by sea ice that you'll find. Kind of like any other body of water, they're important for nutrients to any of the wildlife in the surrounding area and weather as well. So next we're going to talk a little bit about the effect on sea level, specifically the polar contributions to sea level. So one big factor in contributing to sea level is kind of ice calving. Before I was talking about sea ice forming and melting and the cycle of that, but calving is when glaciers, when it's warmer and glaciers lose chunks of their ice. So it's a little bit more extreme, and it contributes to a lot more melting because it's not connected to the larger body, or the larger cold body. And then in general, melting of the polar regions is a huge issue for sea level. If the entirety of Antarctica and Greenland were to melt, the global sea level would increase by 70 meters. So there's quite a lot of ice that's being held in Antarctica and Greenland, and they are melting very rapidly. Kind of not a polar region, but another fun fact, the glaciers in Kilimanjaro are almost all gone, and they've contributed to sea level rise as well. And then when talking about sea level change, you want to make sure you're discussing isostatic versus eustatic change. Isostatic change happens when there is an accumulation of mass on a certain landform, or a decrease in mass on the landform, which causes the landform to either rise or sink, causing a change in the sea level. Isostatic change is very local, and it also happens over a very long period of time. So there are some areas of the Earth now that are still undergoing isostatic adjustment due to changes in mass. And eustatic, it just refers to changes in the sea level that are global and permanent. All right, next we're going to be talking about kind of in conjunction Arctic Ocean, Southern Ocean circulation, and deep water formation regions. I'm going to explain a little bit about the currents first, and then we're going to go into deep water, but they're very, very connected topics. So currents are driven by temperature and by wind. So we're going to be talking about temperature later, but the currents in the Arctic are driven by the North Atlantic Oscillation and the Arctic Oscillation. Those are wind oscillations. And then you have some really big currents are the Beaufort-Gyre transpolar current, North Atlantic current, and the Atlantic meridional overturning circulation. They bring water up from the more temperate regions by the equator to be cooled down and to get nutrients from the Arctic, and then the water is returned. Both the Arctic and the Antarctic circulation, like regions, the purpose is just to transport nutrients and keep the climate like just very like regular and regulated, because the water does get heated up at the equator and surrounding areas. The Beaufort Gyre is particularly important because it holds a lot of the sea ice in the Arctic region. So as it stays in the Beaufort Gyre, it doesn't get taken anywhere else by any of the currents, so it allows the ice to build up as it's moving. But currently, because of the wind patterns and the warming climate, the Beaufort Gyre has been getting faster and faster, and we are actually losing sea ice up there, which is a little bit scary, but we'll have to keep looking into that. And yeah, that's pretty much Arctic circulation. So in the Southern Ocean slash like Antarctica area, we have this really big circular current called the Antarctic Circumpolar Current. So right here, the ACC, which flows this way. It's a circular current, and it forms around Antarctica, and inside you can see these two like big or there's more than two, but there are two big gyres that I want to talk about, called the Ross and the Weddell Gyre. They are formed because or through the interactions of the Antarctic Circumpolar Current and the land mass of Antarctica itself. This here in the Southern Ocean and also up in the Atlantic, there is the formation of deep water. Deep water is just, so as the water gets to the polar regions, it starts cooling because it is cooler in the polar regions, and due to this cooling, the water gets more and more dense and sinks very, very low into the ground or into the ocean, and then you get the formation of deep water and bottom water, which is very, very heavy and very, very nutrient rich, and we're going to be getting into the implications of that in just a second. Ooh. So now we're talking about deep water and their formation regions. So as you can see in this figure above, there are a couple areas of deep water formation, and they are all in the polar regions. So up here and down here, they are big contributors to thermohaline circulation. So kind of let's break apart the word thermo and haline. Thermo, temperature, and haline is salt. So the currents are also driven by changes in density. So as you can kind of see, as the water is formed down here, it just starts to travel along the bottom of the oceans, and as the water warms, it gets brought up to the surface, and through that, it brings up nutrients and such, and that's called upwelling. In these areas of upwelling, you'll find, like, again, very, very nutrient-rich environments and a lot of wildlife. It's very important because there are a lot of nutrients down at the bottom of the ocean that don't get brought up until this upwelling and this thermohaline circulation causes it to. And just in general, there's just like this big conveyor belt right here that you can see of different temperature water circulating, and like I was saying before, this contributes to maintaining the nutrients of an environment as well as the temperatures of the area. We're going to get a little bit more into this in a separate video, but water has a very, very high specific heat, and therefore it can like hold a lot of energy, and by that I mean like in its temperature, it takes quite a lot of energy to move it a degree Celsius up or down in whichever direction you'd like. And so water temperature is very, very important to the climates that it is at. All right, and that's it for polar oceanography. I hope you enjoyed this video, and we'll see you in the next one. Thank you for listening.